Hey guys, so in this video I will be covering finding the midpoint between 2 points. I will start off with some really basic examples, and then from there I will build off it and do more advanced questions and some application problems. And then at the end I will explain why the formula works the way it does. Okay, so here we have our distance formula to find the distance between 2 points. So it's distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So here's a basic example. Find the distance between A, 3, 1, and B, 5, 1. So it doesn't matter which point you decide is point 1, as long as you label it consistently. So if this is x1, then this has to be y1. And that means this is my second point, so 5 is x2 and 1 is y2. So now I'm just going to fill my points into the formula. So distance equals the square root of x2, which is 5, minus x1, which is 3, squared, plus y2, which is 1, minus y1, which is 1, squared, and we take the square root of that. So you could either throw this in your calculator, or if we break it down slowly, we have 5 minus 3, we know is 2, so 2 squared, plus 0 squared. So distance equals the square root of 4 plus 0, which is just the same as the square root of 4. And that is 2. So the distance between A and B is 2. We'll just do one more of those before we get to the harder stuff. So same thing, we could do it different this way this time. This time I'll label this as x2, y2, and I'll have this be point 1. To x1, y1. It doesn't matter as long as x2 and y2 are together, x1 and y1 are together. So this is the formula again, and we're just going to place our x2 and our x1 in their spot, our y2 and our y1 in their spot, and break it down. So distance equals the square root of x2, which is 2, minus x1, which is 0, squared, plus y2 minus y1, so 0 minus negative 1 squared. So our distance equals 2 squared plus 0 minus negative 1 is 1 squared and square root. So we get distance equals the square root of 4 plus 1. So distance equals the square root of 5. And since the square root of 5 is an irrational number, we can just leave our answer like that. Okay, for this one, we have find the length of the line EF. So if you're ever asked to find the length of a line, it's the same thing as asking for the distance from one point to another. So first, let's go through and find what these points are. So E is -1 and 2, -1 on the x-axis, 2 on the y-axis. Our point F is 6 on the x-axis and -2 on the y-axis. So those are the 2 points that we're finding the length of the line between them, which is the same as the distance between them. So I'm going to rewrite those, -1, 2, and 6, -2. Doesn't matter again which one is x1, y1, as long as those are together, and x2, y2. So then we're going to fill it into our distance formula. I'll just rewrite that really quick so we have it. So it's x2 minus x1 squared plus y2 minus y1 squared. Okay, so distance equals x2 is 6, so 6 minus -1 squared. We're going to square root this here as well. Oops, forgot a bracket. Then plus y2, so -2 minus y1, which is 2 squared. So distance equals the square root of 6 minus -1 is 7 squared plus -4 squared. So that becomes the square root of 49 plus -4 squared. Don't forget that -4 times -4 becomes a positive. So it's positive 16. So that means that our distance is equal to the square root of 65. Since that's irrational, we could just leave it like that. Okay, so let's get to the more complicated ones. This question says, determine whether the following triangle is a right-angled triangle. If there is a right angle, state the vertex in which it occurs. So if we want, we could graph this out and look at it and try and see if it looks like a right-angled triangle. But let's start talking about what we know about right-angled triangles. So if we have a right-angled triangle, we know that if this is A, that's B, and that's C, then C squared has to equal A squared plus B squared. So that's Pythagoras' theorem. So we are going to find the length of the lines between each three of these points. So that's going to be the line AB, AC, and BC. And if the lengths of all those lines satisfies this equation, then we know it's a right-angled triangle. If it doesn't, then it's not a right-angled triangle. So let's do the distance between AB So I'll label, in this case, I'll rewrite it, -2, -1 is my A, and my B is 3, -1. I'll make that x1, y1, x2, y2. So distance equals the square root of x2 minus x1, so 3 minus -2 squared, plus y2 minus y1, so -1 minus -1 squared. So our distance equals the square root of 5 squared plus 0 squared. So that would be the square root of 5 squared, which is just 5. So we know our distance from A to B is 5. Let's do our distance between A and C. So A is -2, -1, and C is 3, 3. In this case, I'll make this x1, y1. Again, it doesn't matter as long as our x1, y1 go together and our x2, y2 go together. So my distance between these 2 points is the square root of x1 minus x2, so 3 minus -2 squared, plus 3 minus -1 squared. So that will give me the square root. I'm just going to speed this up a little bit. So 3 minus -2 is 5 squared, oops, need a bracket there, is 25. Here we have 3 minus -1, which is 4. 4 squared is 16. So we then have the square root of 41. So we'll leave that like that because that's irrational. Last one, we have to find the distance between B and C. So I'm going to squeeze this on in here. We'll fit this right down here. So distance for B and C. So my B is 3, -1, and C is 3, 3. So we have x1, y1, x2, y2. So the distance then is the square root of 3 minus 3, x2 minus x1 squared, plus y2 minus y1, so 3 minus -1 squared. So that gives us 0 squared, and 3 minus -1 is 4 squared is 16. So the distance between B and C would just be the square root of 16, which we know is 4. Okay, so now we're going to try and figure out if this makes a right angle triangle. So we're going to see if 5 squared plus 4 squared equals the square root of 41 squared. So just to clarify there, I took the two smaller sides because from what we know about our right angle triangle is the two smaller sides squared would equal the longer side squared. So 5 and 4 I know is smaller than the square root of 41 because I know that 6 squared would give us 36. So the square root of 41 has to be 6 point something. You could also check that in a calculator and do it that way, but we just want to make sure these are our smallest sides equals the bigger side. So we get 25 plus 16 equals 41 square rooted then squared is just 41. So 25 plus 16 is 41. So we get 41 equals 41, which of course is true. So that means that the points A, B, and C do make up a right angle triangle. Okay, so we also found out that the right angle happens between 5 and 4, between our shorter sides. Same with up here, it's between A and B. It's that guy there. So we have to figure out which point was between 5 and 4. So this was the distance from B to C for our distance of 4, and from A to B gave us a distance of 5. So we know from A to C gave us our root 41, just if we draw that out there. So we know our right angle triangle. So the right angle occurs at our point B. And our point B was 3, -1. All right, on to this stuff. So this gets a little bit trickier, but same kind of concept. So find A if the points P, 2, 3, and Q, A, -1, are 4 units apart. So again, let's write our distance formula. We know that it's the square root of x2 minus x1 squared plus y2 minus y1 squared. And we're going to label these. So I'll make this x1, y1, x2, y2. You could go the other way as well if you'd like. So distance, oops, in this case, we know our distance. We know that it's 4. So we're going to plug that in for our distance. 4 equals the distance between these 2 points, and we'll fill it in. So x2 is A minus 2 squared plus y2 minus y1, so -1 minus 3 squared. Basically, we're going to rearrange this because we're solving for A. So right off the bat, actually, I'm going to square both sides. If I square both sides, that's going to get rid of this square root here. So we're going to have 16 equals A minus 2 squared plus, while I'm at it, I'll put these together, -4 squared. So that's 16 equals A minus 2 squared plus 16. So what I could do is I could subtract 16 off both sides. That will get rid of that guy. And actually this will make this side 0. So we have 0 equals A minus 2 squared. If we want to get rid of a squared, we just square root both sides. So those are going to cancel. The square root of 0 is still just 0. So we have 0 equals A minus 2. So if we add 2 to both sides, we'll just squeeze it on over here. We're going to get 2 equals A. So that's our answer. The way we can check that, which I'll leave that for you guys to try, is we can take 2 and put it in the place of A, because we know that now Q should be 2, -1. We can then check that the distance between P and our Q should be 4 by putting it into the formula. All right, let's do one more of those. Slightly more advanced on this one. This question says, find the relationship between X and Y if the point P, X, Y, is 3 units away from the origin 0, 0. So same concept as before, we're gonna have our distance formula, which equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so up to you again if you want to make this x2, y2, or you can make it x1, y1. It'll all work out in the end. This would be x1, y1 in this case. So I know my distance in this question is 3. So I'm going to have 3 equals the square root of x minus 0 squared plus y minus 0 squared. So we want to write this in an equation where we end up with y equals with x on the other side. So we have 3 equals, just simplify this down, x squared plus y squared, because x minus 0, y minus 0 is still just x and y. Now if I want to get rid of the square root, I can just square both sides. So that's going to give me 9 equals x squared plus y squared. It totally depends on how far your teacher wants you to go, but in this case, I'll rearrange until we get y equals, just to go that step further. So I'm going to move over this x squared by subtracting x squared from both sides. So now we have 9 minus x squared equals y squared, but that's a y squared, not y. So if I want to get just y, I have to square root both sides. And the square root of y squared would just be y, and that is equal to 9 minus x squared, all square rooted. So there we go. So that's the relationship between x and y if p is x comma y, and we know it's 3 units away from the origin. Okay, so those are all the examples I have for you, but now we will just explain where this formula comes from or why it works. And it actually is just an expansion or an extension of the Pythagoras theorem. So let's take our points. We're going to find the distance between this point, and we know it would be this line here. But this diagram has nicely drawn it as a triangle for us. So I'm going to fill this in as x1, y1, and x2, y2. So if we strictly just think of this distance, that distance there would be whatever x2 is minus whatever x1 is, because x2 would be the distance from here all the way to there, and x1 is here. So if we want to find from here to here, we could just subtract x1 from x2. So this guy is x2 minus x1. Same argument, but I'll explain it again. This side here, we know that this is y2, and this point, or this line here, is whatever y1 is. So if we want to find this, this would be y2, which is all of that length, minus y1, which is that length. So this would be y2 minus y1. Okay, then from Pythagoras' theorem, we know that this side squared plus this side squared would equal this side squared. So we want to find the formula just for this side. I'm going to call him distance, because that's what he is. So I know that distance squared would equal this side squared, so x2 minus x1 squared, plus this side squared, so y2 minus y1 squared. So I don't want the distance squared though. I just want to know the distance from this point to this point. So to get rid of a squared, I could just take the square root of both sides. So if I square root this side and square root this side, I bet you're noticing it's starting to look like the formula. Those will cancel there. So I will have that distance equals, and there it is, x2 minus x1 squared plus y2 minus y1 squared.